Yes, good morning, everyone. I hope you can hear me. So welcome to another episode of our training. So if you cannot hear me or you're facing some issues, you can just reach out at the chat section. Okay, we resume. So our today's training is a progress from for the DHSA VSS training. We can hear you. Okay, thank you, Jean Shimiyana, I think from Rwanda. So today we are going to do a training. We're going to proceed with the training, our previous training for DHSA VSS certification. So it's part. It's the first section. So resume. Sorry for that. So if you have your camera turned on, kindly you can switch it off. Maybe later when we'll have a session for interacting amongst ourselves. But for our case today, we are going just to do. I'll be the one presenting. Yes, we can hear you, William from VDS. Okay, thank you, William. So I'll begin by introducing myself. My name is Shelton Kipwech. I'm from the Tech Support Department of Kahua Technology. So we are located at 67 Mudidi Road, Westlands. So we have had a previous sessions on DHSA training, and yesterday we had 3 sessions. So we had quite a number for the first and the second session. Then the third session, people decided to disappear. But today we'll be having 2 sessions today, a 30 minutes session. Then we resume at 11:45 for another session. The reason why we decided to do theory today is that we have realized that there's quite a lot of theory to cover for the training part of the certification. That's why we need to hurry up, considering. Okay, there's an echo. Kindly, you can tell me if the echo is off from Gashuka. Yes, if you can still hear echo, you can just tell me. So we realized that the training is more a lot of theory. So we decide to do we focus more on theory. Then we'll have other sessions for practical part of it, considering that we have been doing practical sessions on Saturdays. So today's sessions will be different. It will be theory. Also next week we're going to do a theory part. Okay, now thank you. Yeah. So today also we are going to do theory part to cover more ground on the training of this course. So a question from Ben Odieng. Ben Odieng, maybe you can do interaction in the chat section. So for questions, maybe we can get to. We'll get to interact. Maybe later we do a session on that.
Oh, can you hear me?
Yes, we can hear you. What's the issue?
Okay. As we proceed,
yes.
I just have a concern. There are some basics that we are not getting clear Would you mind at least after doing this training,
Yes.
maybe one of these fine weekends, maybe it's a Saturday or so,
Yes.
at least we do it practically in physically now a working environment, like
Oh,
for
yeah.
example.
Yes, I understand. For that case, we have been doing a practical session. So last week we had a practical at our offices in Mitsumi. So this is applicable for those who are in Kenya. Yeah.
Oh, fine.
Okay, I think we can resume now. So I'm going to let me just share with you the overall cost outline. So there are quite a number of slides that we need to cover for the case. That's why we need to hurry on the theory part of it. Also, people get tired when you do quite a lot of theory for a long period of time. So this is the course materials that you need to cover. So you can zoom your screens. For my case, I cannot zoom because it's an Explorer. So you see, we have to do a technical basic, a product introduction. So we have to cover all these slides. So I need to rush on them, and considering we're in the first folder. So we need to cover all this information. You need to do DSS. We need to do alarm system success control for the certification. It's just not only video part of it, just that one. Okay, now I think that's enough for introduction. So we can proceed. So the exam will be, I repeat again, will be 60%. Will be pass mark is 60%. It will cover theory and practical part of it. For those who are in different countries, we'll organize for the same because we have our technicians coming to those sites. You can do certification for you. Also, the video is the session is recorded. It will be available online with the link that I shared with the joining link for the training. So if you need to do a reference letter, you'll just check it on YouTube. It's available for downloads. And in case you face anything, you can just contact me directly. Okay, now we continue. So today we're going to do basic knowledge of network. I'll be rushing on this case. So this is just a basic networking, which will it's just a foundation on the certification part of it. So by the end, I should be able to understand switches. I think most of you are aware with this. We'll be able to do about different functions, no applications of field, the video surveillance with the networking area. So the basic concepts of network we're going to handle today. So we have different types of networks. We have a local area network. We have metropolitan area network, wide area network. So most of the cases you do most of the cases, if about 80 or 90 or 70% of surveillance are done in a local area network, with a few doing wide area network side. That is cases for P2P and remote access. So a definition of a computer network, combination of different computers to achieve communication. So one of the key parts you need to know about is about distribution in this part of definition of the network. So LAN, MAN, or WAN. So a LAN is a local area network. If you have a switch connect your computer to a switch and maybe other device like another PC, you get to do a LAN. LAN is the foundation of a network, that low-level part of the network. Then you'll proceed like this. So you begin with the LAN, proceed next to MAN and a WAN. So a MAN, metropolitan area network, is a bigger size version of the LAN, and the WAN is the wide area network, commonly referred to as the internet. So from the layman's part is the internet part. A network topology, we have different types of topology that exist. We have a star, ring topology, bus, mesh topology. So a star topology is just considering how a star looks like. So the topology, I think it exhibits its name from this point. So you have your computers connecting to a common switch in a star format. Not necessarily because the ports will basically go to the ports of the switch. So just one center device, then connecting the end sides. A ring topology would have a case where you have devices interconnecting with each other to form a ring-like structure. A bus topology. For a bus topology, typically you'll have a common connection point for devices. So you have a bus line that will connect all the nodes with each other. A mesh is just a hybrid topology, considering a mesh can do ring topology and star port topology, can combine that. So to form this kind of mesh structure. So OSI reference model, I think we are back to school. The OSI reference model, you can do a search, more search on the same of this, because most of the companies that do certifications need you to have a basic knowledge of the network, including the OSI model and the TCP/IP model. The reason why we have the OSI model is because of troubleshooting cases and help you to build that firm foundation of the networking stage. So for the OSI model, you can search on the same. You need to get to know the OSI reference model. It's called the OSI reference model. So from the physical layer, MAC layer, network layer, transport layer, session, presentation, and application layer. So it's a total of 7 layers. So whereby the physical layer represents the basic part of the network, considering about cabling. So the data handle at this point is bits, in terms of bits. So this is the zeros and ones, because considering a cable would typically transmit a digital signal of zeros and ones. So while we are doing the OSI reference model, we are talking about IP cameras, not the HD ones, because HD will do analog signal, this one will do a digital signal. Digital signal is about zeros and ones. So the physical layer. A MAC layer. So all this information, I think we need to know, because for the certification part of it, it will cover the theory, more theory. So you need to know a lot of theory for this case. So for the application layer is the way the user interacts. Presentation layer is formatting of data to be able for the user side. The session layer will handle sessions between different computers. Like for the case, maybe if you are streaming a video from the internet, how you receive that service, the session layer will do that handling of information. So from the end side and this end side. So the transport layer will work with the routing of information. So this transport side is where you do routing, most of the cases routing, yeah. So the format of a packet, and need to know this side. So in the transport layer, we have TCP and UDP. Okay, you can do a research more on the OSI reference model. So a TCP/IP model is just like the OSI model. The difference is that this one is an old version. So TCP/IP came first. It was created by DoD. It was doing it is simplified version of OSI. So it was the first layer. So you get network layer, network interface, network layer. So this is the equivalent of physical layer and data link layer. So you can do a research more on this. So an Ethernet frame, from the references model, either TCP or OSI model, from this data link layer here, we deal with the frames. So a frame format would look like this. So a frame is used to do a communications between, if you have your computer connected to a switch, the computer will send frames to the switch, not, yeah, it will do communication between the NIC cards without information going outside the network. It will do with using an Ethernet frame. So the format of a frame looks like this. You can do a research on the same. I'll not dive into this because we are doing a rush on the same. So the information available in the internet is the same that we're presenting at this point. So MAC address. So MAC address is as a unique identifier for the device in a network. So MAC address are unique in the network. So apart from that, for our devices we have serial numbers. Serial numbers are also unique for every device in which the company produces. So an IP address. So an IP address is used at this network layer of the model, of the reference model. So an IP address format will typically look like this. So at least you get to know the basic about IP addressing. So those numbers that you put like 192.168, the common ones, the 10.0.0.1, those are the IP addresses for the devices. So an IP address will help communicating between different devices in the network. So if you have a big network or a local area network with a router in the network, and the router will use the IP address to identify devices in the network. So different versions, we have IP version 6 and IP version 4. So our devices uses IP version 6 at the end side. So if you have an NVR, a DVR, it will typically use IP version 4. IP version 4. Whereas we have devices that support IP version 6. So these devices include like the advertising devices like LCD signage device. You can see some of the devices like the ones in Sarit Center. So that is that's the advertisement device that can use IP version 6. So you can do a translation for the IP version 4 to version 6 using your router. So a minute. So an IP address, introduction to IP address. So if you have an IP address of zeros, it will mean all network address. That is all the devices in the network. If you have an IP address of all ones, it means a broadcast for the network. So like if you say 192.168.255.255, that is a broadcast address. So I had a friend of mine who was configuring video intercom in the network, and the friend decided to use 192.168.1.255 as the IP address for one of the videos. So we were trying to access the device, but it was not. So I later told the client to just change the IP address, considering a broadcast address will not be used in the network as the IP address for a device. Okay, we resume. So an IP address is formation between a subnet mask. So a full IP address will have an IP address for the device, subnet mask to identify which network the device belongs to, and a gateway. So from Gashua is asking for me to send the slides. Unfortunately, I wanted to send the slides to you guys, but I can't because of rights issues in the company. So if I tried sending the slides to you, you will not be able to use them because it is right protected. So you require to log in and to the domain network. So about addressing, maybe if you're not comfortable, I think you can do a research on this, because or maybe you can just talk roughly about it, because even most of the devices that you'll configure, typically you don't need to dive more into the subnetting and do in the subnetting part of the IP addresses. But how do you get a subnet address? So you get, the way you get a subnet address, you do a bitwise operation between the IP address and the subnet mask. This one will give you a broadcast address, subnet or subnetwork address. That is the gateway which you'll use as the gateway. And the broadcast address, if you do the OR operation, get the broadcast address. How to calculate the host number of subnet? So a case where you'd need to do a calculation for host number is the cases maybe where you are doing large number of devices and you need to put all those devices into one network. Considering it's good to have one network for surveillance and everything into one network to avoid those complexities of, you just simplify your work. So if you want to calculate the number of devices, so host number in the subnetwork, you just 2 raised to n minus 2. Minus 2 here is the number, is the IP address for the network and the broadcast address. You can do more research on this. I'll just skip. Okay, so this is important. So while doing configuration for most of the devices, like if you want to log into the most devices that support web interface, like cameras, video intercom, VTOs, devices like maybe you want to log into a switch, you might encounter a problem where you are trying to log into the web interface of a device like VTO, but you cannot get a response back to it. The reason as to why you're getting that is because you're not in the same network segment. So if you want to configure devices, typically set your IP address to be in the same network. So you would do a search on config tool, get to see the IP address for the device, then configure your computer to be in the same network segment as the device. So the way you do configuration, you go to network adapter. This is for the Windows case. Then you do changing for the IP information at this point. So no need to set the gateway. So common commands, pinging the local area network. So while doing troubleshooting for your access to devices that were products, you need to do troubleshooting from the basic level of the network. That's why you need to get to know about the TCP/IP model. So you troubleshoot from the first layer, that's the physical layer. You confirm that the cabling is very well, and you also confirm that your network adapter is okay. So how you do test your computer's network adapter is by pinging the local host. This is 192.168.27.0.0.1. So if you get a response from the NIC card, meaning your network interface card, where you plug in your cable, is doing fine. So address resolution protocol is used to identify devices in the network. So ARP mostly is used by switches to get to know which devices are in the network and also try to communicate between those devices. So what a switch will do is just, who is on this IP address, tell me your MAC address. So your PC will reply with the ARP request and giving the MAC address. That's why the switch will be able to forward information very fast. So while for those who have done a Cisco certification or CCNA, you realize that this part is core. But for our case, we just need to know what ARP is, because most of the devices are made to be user-friendly and easier for you to configure. So you just need to know what is an ARP and the MAC address information. So we're going to dive into basic principles of a switch. So a reminder, we'll do a break at 11:45. Then we'll resume at 11:45. So today we are going to have 2 sessions. We need to rush the theory part of it. So we're going to have 2 sessions, a break for 10 minutes at 11:35. Also, the video recording, the training is recorded and will be available online on YouTube. So a switch application. So going to do a basic knowledge of a switch. So a switch application will be used in a network where you need to interconnect devices. So a topology, basic topology using a switch operation is indicated from the diagram you can see. So you're able to see. So if you are not seeing, if you're not able to see, you can detach the chat section so that we get to help each other. So you can see for this case, we have a switch connecting a camera. It's a PTZ camera, or is it a speedom or a PTZ? So we did. So some time back, we did a training on cameras. So these are a PTZ with an AR connecting a IP phone in different desktops. So a switch will do interconnection of devices in the network. So a MAC address, learning and forwarding. So this is the working principle of a switch. So it has different working principles. So learning and forwarding is where the switch will just get information, read the address and forward the information based on the MAC address of the devices. So for this, a typical scenario is like host A will send information. So at the beginning, MAC address is totally blank. So we connect the device, it will do an ARP request. If you get back about the MAC address of the devices, once the switch gets to know the MAC addresses for different devices, it will record it in the MAC table, then use that information to do learning and forwarding of information, sorry. So we have different types of switch. So you would typically categorize your switch either as a layer 1, layer 2, or layer 3. But what we have all these 3 cameras. So a layer 2 switch, you just so if you're going to do, you can check on our website for transmission side. We have switches that you have layer 2 switch, which is unmanaged, meaning you can't log into the web interface. The switch just will do its functions automatically. Then we have layer 2 managed switch. So this is the layer 2 plus switch. So these are kind of switch that will do functions like changing the POE information, doing MAC address populating by yourself, and do custom settings in the switch. And then we have layer 3 switch, which will do, apart from doing switching, it will do routing information. So that's how you get to classify these different kinds of switches. So typically you'll use a layer 2 switch in a basic network, like using cameras, intercom, where you don't need to focus more on speeds, just need to get that enough communication. Also for the layer 2 switches, we have switches that can do different speeds. So we'll get to know later. So maybe you can know without function only has VLAN, STP, IGMP, snooping, and so on. So a VLAN is just categorizing the devices into one virtual local area network. Okay, you can see different type of switches that we have. So I think most of you have interacted with this, the first one. So these are unmanaged switch, meaning there's no need for you to do configuration for the switch, considering everything has been done automatically in the switch. So we have a smart switch. So this one, you can, some essential features like VLAN, STP, quality of service, and access list. So all these features are basic software features for switches with smart support web management method, meaning you can log in on the web interface for this switch and do configuration. So manage switch, a wide range of features. So for manage switch, you can do advanced features like routing. So for the classification of switches, we have switches that exist at different levels of the network. So you have access layer switch. So this one will connect to the end devices like cameras, indoor monitors, etc. Then you have convergence layer switch. So this type of design is called hierarchical network design, where you have different levels of network. So access, core, and distribution layer. So access layer, convergence layer, and the core layer. So the speeds for this and the performance for switches, as it goes up, the performance and speed increases. Switches performance. So we have switches that support Ethernet ports, SFP ports. SFP, these one are fiber ports. A combination of SFP and Ethernet port. So for this, for the cases for combo port is about doing SFP as the uplink port, while doing the, you see these are SFP ports. So doing SFP as the uplink ports while doing this one as the access ports. So we have different types of switches: standard, fast Ethernet, and gigabit. Gigabit speeds of 1 to 1,000 gigabytes, 1,000 megabytes. Sorry, we have Ethernet. We'll get to know the naming convention of different products, so that you know when you're purchasing a device, by reading the name, you'll be able to know what these devices offer, what are the speeds, and so on. So a switch performance will be based on the bandwidth it can support, the backplane bandwidth, the switching capacity, packet forwarding rates, and the buffer. So you need to know this one while doing a suggestion for clients or doing suggestion for projects that require switches. So for cases where you have a project that requires switches, you need to be able to identify a switch, know what that switch performance offers, so that at the end result, you don't have to get into that problem where you're having issues with the switch, saying the switch is bad or something like that because of your choices. So, okay, backplane width. So the backplane bandwidth refers to the bus bandwidth speed available for communication between line cards and chassis on the switch. So the larger the better for the backplane width. A switching capacity is refers to how fast the information is transmitted between the CPU and the bus. So the bus is it's like let's say the ports. So the CPU and the ports. So this switching capacity is smaller than backplane, but they're equal to each other in fixed port number switch. So packet forwarding rate. So maybe you can get to know the difference between a packet forwarding rate and switching capacity. So if the packet forwarding rate is greater or equal to value calculated by the following formula, it means. So we're going to take a break, then we'll come and recheck this one, then we proceed. So we take a break for 10 minutes, then we resume at 11:45. So come back for the same.